Hey everyone, it's Miss Flowers. Today we are going to be learning about lateral area and surface area of cylinders. Okay, so new shape. We already talked a bunch about prisms. We're moving on to cylinders. So this is day 4 note, so it's going to go along with day 4 homework or homework 4. That's going to be the assignment for tonight that goes along with these notes, just to let you know. Okay, so the warm-up is asking us to list as many real-life examples of cylinders that we can think of. So if you want, you can pause it right now and write a few that you think of, or just keep going with, and we'll write some down. So I can think of off the top of my head, like a soup can, like a tuna can. That's kind of a different type of cylinder, but they're both cylinders. How about roll of paper towel? Or like a vase. Okay, I'm just looking around my apartment, but you get the idea. Anything that's shaped like what we just listed would be considered a cylinder, okay? So down here some cylinder vocabulary. We have bases, which that's kind of is what you think it would be. It's the prisms have bases, and so do cylinders. They have bases too. It's the circular top and bottom. So if you would look at this cylinder over here at the right, the top right here would be a base, and then if you would picture down here, there's also a circle in that at the bottom. That would be a base as well. Then we have the radius, which that word should be familiar to you. That would be halfway across the circle, right? So from the center to the edge of the circle is called a radius. So basically halfway across, right? And then the height or altitude of a cylinder, that's the perpendicular distance from base to base. So looking over here, right, the height is just, and Mr. Voss made a good point in the last video. He described the height as how far is it from one base to the other base, right? So that's a good way to think of it, because sometimes a cylinder might be on its side, or any 3D shape might be on its side. So you wouldn't necessarily always want to say how high is it into the air. It's a good way to put it, the distance from base to base. So like right here, that would be the height of the cylinder. Okay, so now let's talk about formulas. So just like for prisms, there was one formula for lateral area, one formula for surface area, same thing with cylinders. So we're going to kind of answer a few questions to lead us to the formula for both of these. So write the formula to find lateral area of a prism. So hopefully you remember this because it was from just a few days ago. The lateral area of a prism was the perimeter of the base times the height, right? Remember that? So number 2 says a cylinder does have a height, but the base doesn't have a perimeter, right? What word do we use to describe the perimeter of a circle, and what is the formula used to find that word? So when you're talking about perimeter of a circle, that's all the way around the circle, right? If you have forgotten, that word is circumference. Okay, maybe it sounds familiar to you. Hopefully it does. So circumference is that distance around the outside of the circle, right? And what is the formula to find? So that's that word, right? And then what is the formula used to find that word? It is 2 pi r. So 2 times pi times the radius. Okay, so now so use your answers from questions 1 and 2 to adjust the lateral area of a prism formula to match the specifications for a cylinder. So here we have lateral area for a cylinder. Instead of saying perimeter of the base times the height, we're going to say 2 pi r times the height, right? Because we don't have a perimeter of a circle. We have a circumference of a circle. So we're going to take all this part right here and kind of plug it into where the perimeter of the base went. So here's our important part here. That's lateral area for a cylinder. Okay. So now let's talk about surface area of a cylinder. Write the formula for a surface area of a prism. So again, we just did this. Surface area of a prism is the lateral area plus 2 times the area of the base, right? So since this says, since B represents the area of the base, and the base of any cylinder is a circle, we can replace that capital B with the formula for the area of a circle, which is, if you don't remember, pi r squared, right? That's the area of a circle. So now let's rewrite the surface area of a prism formula to match the specifications for a cylinder. So surface area for a cylinder would be still lateral area plus 2 pi r squared, right? Instead of saying 2 times the area of the base, we can go ahead and say pi r squared because the base is always going to be a circle, right? Okay, so here's our important thing here. So now these two things are our main takeaways. Here is the formula. Oh, that is not what I wanted. Maybe this will be lighter. Here is lateral area of a cylinder and surface area of a cylinder. Still not the greatest, but you get what I'm saying. I'm trying to emphasize that part. Okay? So let's do some examples. So here we have our first one. It wants us to find both lateral area and surface area. And if you notice down here at the bottom, it says it wants exact and it wants rounded. So remember, when it's exact, that means do not type the pi into the calculator. You want to just attach the pi, type everything else into the calculator, and then attach the pi to the answer afterwards, right? Because as we know, pi is this 3.1415 blah blah blah, like it goes on forever, right? So when you put that symbol pi, that's representing every single digit of pi. So that's not a rounded answer, that's an exact answer. And then when it says rounded answer, you would want to type the pi into the calculator and round to like the hundredths place, right? Normally we just do a couple decimal places. So, okay, so let's first find the lateral area of this cylinder. So remember, I'll just write this. Remember, it's 2 pi r h. So 2 pi, the radius here is at 8, right? This part right here, that's the radius. And then the height of the cylinder is 7. So when you do, I always do like, okay, so first let's find the exact answer. 8 times 7 times 2, and that's 112. Notice I did not type the pi into the calculator. I just leave that, right? So then that means the lateral area would be, the exact answer would be 112 pi, and this is kilometers squared, right? Because we're talking about area again. So as we go through this, we're going to kind of be switching back and forth between volume and lateral area and surface area. Whenever you're doing volume, you're going to do units cubed. Whenever you're doing area, lateral or surface area, you're going to do squared. Okay, so just to keep that in mind. Also, sorry, I forgot to say something up here, so let's scroll back up before we keep going. I just wanted to reiterate what lateral area versus surface area means. Lateral area, if you're picturing on a cylinder, the lateral area, remember, is all the area of the outside of the shape except for the bases. So if you would be picturing like that soup can, right, the lateral area would be just the area where the label goes, not the top and the bottom, right? Not the top or the bottom of the can where there's no label. Lateral area would be just the label, whereas surface area would be any surface on the can at all, around the whole, the sides of it and the top and the bottom. Okay, so I just wanted to make that clear. So back to this. So we just found the lateral area, the exact lateral area. So how about, while we're on lateral area, let's just find the rounded one at the same time. So now what you would want to do for rounded is you would want to type 112 pi into your calculator. And so that is 351 it's 858, so that would be 86 kilometers squared. Okay? So that's the whole exact versus rounded thing, right? So I would just do it like this all the time. Get your exact answer, and then you can type it in to find the rounded answer. Okay, so now let's find the surface area of this cylinder. So remember, surface area is just whatever the lateral area is plus 2 pi r squared. And it makes sense that it says 2 pi r squared, right? Because we want the lateral area, which is the area around the sides, plus 2 circles, the top and the bottom, right? The area of 2 circles, so 2 pi r squared. So that makes sense. So we just found, I'll do it this way. The lateral area we just found is 112 pi. Let's just keep it exact for this. And then this part, okay. This part would be 2 pi, the radius is 8, remember? So 8 squared. So when you simplify this whole thing, this would be 112 pi plus, so that's 8 squared, which is 64, times 2, which is 128. So this whole thing would be 128 pi. When you add these together, remember those pi's kind of act like that. Looks like they're like terms, right? It's almost like it says like 112x plus 128x. It doesn't say that, but I'm meaning like you can combine them in that same way. So if you just do 112 plus 128, that's 240. So you're 240 pi. So our surface area, and that's kilometers squared. So put that down here. Our surface area is 240 pi kilometers squared. That's our exact answer, right? And then to find our rounded answer, just type 240 pi into the calculator, and that's 753.98 kilometers squared. Okay? And we're done with that one. Okay. So again, as always, if you need a second to let it process, kind of look through the work again, just pause the video or go back and rewind. Okay, but I'll move on to example 2. So here we go. Lateral area. So let's do that first. Remember that's 2 pi r h. So as long as you know what these letters stand for, you're going to be good, right? Of course, if it ever comes to the case where we're going to be testing or quizzing on this type of stuff, you would of course be given a formula sheet. You're not going to have to remember all these, but you will have to know what these letters stand for, right? So 2 pi, r is for radius, h is for height. So 2 pi, now be very careful here. Do you see this line that's going all the way across the circle? That's a diameter. That's not a radius, that's a diameter. So you have to be very careful that you're not just going to automatically put that 12 into the formula here, right? The 12 is the diameter. So that means that halfway across, right, from the center, the radius would be 6, right? So our radius is 6, and then our height of our cylinder, right? Notice how this time the cylinder's on its side. So the height is from base to base, right? So that height is 14. So when you do 6 times 14 times 2, that is 168 pi. And it's centimeters squared. So that's our lateral area. Let's put it down here. 168 pi centimeters squared. And that's the exact answer. So let's get the rounded for lateral area. 168 pi is 527.79. So 527.79 centimeters squared. Sorry, my handwriting is really bad if I don't zoom in, but anyways, hopefully you can read that. 527.79 centimeters squared. Okay, so that was lateral area. And now we can do surface area. So remember, it's whatever we just found plus 2 times the area of the circle, which means 2 pi r squared. So we just found that the lateral area is 168 pi plus 2 pi. Remember, the radius is 6 and squared. So leave this part. this would become, well, 6 squared is 36 times 2 is 72. So 72 pi. When you combine these, so 168 plus 72, that's 240 pi. Centimeters squared. So that's the exact answer. 240 pi centimeters squared. And in order to get the rounded, just type that in the calculator. 240 pi, which is, oh yeah, we just did in the last one, 753.98 centimeters squared. Okay? So, these next two problems, examples 3 and 4, are exactly like 1 and 2. So here's what I want you to do. Can you please pause the video right now and try 3 and 4, an honest try, right? Give it an honest try. You can do it. And then after you try 3 and 4, you can keep playing the video and make sure you did them right. Okay, I will go through and do the work for these, but hopefully you pause the video and actually tried these. Okay, so same thing for 3. It's exactly like 1 where it already just gives us the radius, right? It gives us what we need for r. So the lateral area would be 2 pi r h, 2 pi, the radius is 12, the height is 30 this time. So when you do 12 times 30 times 2, that's 720 pi meters squared. Okay, that goes down here in the exact 720 pi meters squared. Let's get that as what it is for rounded. 720 pi is, okay, 2,261.95 meters squared. Okay, that was the lateral area. Then surface area would be, remember, that lateral area plus 2 times the area of circle, 2 pi r squared. The lateral area that we just found, oh my goodness, is 720 pi plus 2 pi, the radius is 12 squared. So this becomes 720 pi plus, so 12 squared is 144, times 2 is 288. When you add those together, you have 720 plus 288, that's 1,008 pi meters squared. So that's the surface area. So let's put that here. 1,008 pi meters squared, and then that rounded as a decimal, when you type that in, is 3,166.73 meters squared. Okay, hopefully you had tried that one, and hopefully you got it right. If not, then hopefully you see your mistake. That's fine too. So example 4 is just like example 2, where it gives you this whole entire diameter across, so you don't be tricked by that, right? You need to make sure that you know that would mean the radius from the center to the edge is 11, right? Okay. So lateral area, 2 pi RH. So 2 pi, the radius is 11, the height is 10. This is a little tuna can or something like that, right? It's a little short cylinder. Sorry. So that would be 11 times 10 times 2, which is 220. This one's feet squared. 220 pi feet squared. So let's put that down here for the exact. And then for the rounded, 220 pi is 691.15 feet squared. Okay. And then surface area for this can, or this cylinder, and I'm just assuming it's a tuna can, but you know what I mean. Surface area for this cylinder would be, so the lateral area plus 2 pi r squared. So that's 220 pi plus 2 pi, the radius is 11, remember? So that is 220 pi plus, so 11 squared, 121 times 2 is 242 pi. So 220 plus 242 would be 462 pi feet squared. So 462 pi feet squared. And then to get that as a rounded, 462 pi is 1,451.42 feet squared. Okay? So those are our more like just straightforward types of lateral area and surface area of cylinder problems. Down here, we have applications, right? So this chapter is all about 3D shapes, which we see all over the place in our real world. So these types of problems kind of lend themselves to applications and real world type of stuff. Okay, so this first one says, Morgan built a kaleidoscope with a 20 centimeter barrel and a 5 centimeter diameter. So if you're picturing over here as a kaleidoscope, hopefully you guys know what these are, because when I was a kid, these were awesome. But 20 centimeter barrel, so that would mean the height is 20 centimeters. Oh, jeez. The height is 20 centimeters. And 5 centimeter diameter. Okay, so all the way across here would be 5 centimeters. Okay, that whole diameter. She plans to cover the barrel, but not the ends, with paper of her own design. How many square centimeters of paper will it take to cover the barrel of the kaleidoscope? So not the ends, right? So that would mean, what are we looking for? Just the lateral area. We want the lateral area because we don't want the ends. We just want the sides. So remember, that's 2 pi r h. So the radius is, the diameter is 5. So that would mean that half of that, we only want from the center to the edge, would be 2.5, right? Half of 5 is 2.5. So that's our radius. And the height of our kaleidoscope is that 20 centimeters, right? That's how long it is from base to base. So when you do 2.5 times 20 and then multiply that by 2, it's 100. So 100 pi. Okay, and since we're talking about, well, it would be 100 pi centimeters squared, right? But like, since we're talking about how many square centimeters of paper will it take to cover, it probably would make more sense in context to just get a decimal and round it. You're not going to go to some store and be like, I need 100 pi centimeters. You know what I mean? So let's just give a rounded answer. So 100 pi would be 314.16 centimeters squared. That's, I mean, I guess it makes more sense, you know. So that's how much paper we would need to cover the sides of the barrel of the kaleidoscope. Okay, so then this one, next one says, a drinking glass is shaped like a cylinder with a height of 7 inches. Ooh, a height of 7 inches and a diameter of 3 inches. What is the surface area of the drinking glass? But remember this hint. The glass has an open top, right? So that means, if you think about it, right, normally our surface area is the lateral area, which is the sides, plus 2 pi r squared. But this time, there's only the bottom of the glass. There's not the top. There's not 2 circles. There's only 1. So we actually don't need that 2 right there, right? There's only 1 circle at the bottom. So now here's kind of our modified formula that we're going to work with right now, because we don't need the top. So, but first we need the lateral area. So let's do that first. Over here, let's find the lateral area. That would be 2 pi r h. So 2 pi, remember the diameter is 3. So that would mean our radius would be 1.5, right? Because 1.5 is half of 3. So plug that in for r, 1.5. The height of our, what are we talking about? Our cylinder, our drinking glass, is 7 inches. So when you do 1.5 times 7 and multiply that by 2, 21 pi. Okay. So that's our lateral area. So we need that to plug that in to find surface area. So let's do that. So we just said that was 21 pi. So 21 pi plus pi, the radius was 1.5, we said, squared. So that's 21 pi plus 1.5 squared is 2.25 pi. So when you add these together, 21 plus 2.25, so that's 23.25 pi inches is what we're talking about, inches squared. But again, like, this is a real world problem, so let's not have the pi in there. We want to just get decimals. So when you do 23.25 times pi, that's 73.04 inches squared. Okay. So that's how much, what's the surface? Yeah, that's the surface area of the drinking glass. Okay. And again, at the end of the day, if you were to leave your answers as the exact with the pi, that's not a big deal. And I'm pretty sure Mr. Voss would probably not think that's a big deal either. It's just, it kind of makes more sense in the context of the problem to change it to a decimal. Okay, so last question. It says, aluminum is needed to make various types of cans. Given the dimensions below, which can requires more aluminum to be made? So think about for a second, if we're just talking about the aluminum that's on the can, okay, that's around the sides and the top and the bottom. So that would be, we are trying to compare surface areas, right? Not lateral areas, because that would be just the sides. We want to know the aluminum is everywhere on the can. So we want to know, we want to compare the two surface areas of these two cans. One of them is a Kickstart can, all y'all's favorite drink from the vending machine, Kickstart. The other one is a tuna can. It's more shorter, wider, you know what I mean? Okay, so it's clearly one is a tuna can, one is a tall, skinny can, like a Kickstart. So it says which can requires more aluminum to be made. So basically, which one has the higher, or which one has the bigger surface area. So let's do both. So first, let's find the surface area of the Kickstart. So remember, well, first, you know, we need the lateral area first to be able to find the surface area. So let's start with that. Let's find lateral area of the Kickstart. That would be 2 pi RH. So 2 pi, the radius of that Kickstart, well, across the whole thing is 2. So then that would mean the radius would just be 1, right? And the height is 4. So 1 times 4 is 4. 4 times 2 is 8. So this is 8 pi. Okay, cool. So now, knowing that, we can do the surface area, which is the lateral area plus 2 pi r squared. The lateral area we just found was 8 pi plus 2 pi, the radius is 1 squared. This would be 2 pi, because 1 squared is 1 times 2 is 2. So this would be 8 pi plus 2 pi, so that's 10 pi, which, again, since it's a real-world problem, let's just change it to a decimal. So 10 pi is 31.42. And it's inches. Okay, so that's the surface area for the kickstart, 31.42 inches squared. So now let's do the same process for the tuna can so we can see which one had the bigger surface area. Okay, for the tuna can, first let's find the lateral area. The radius, again, the whole thing across is 4, which would mean the radius would just be 2. And the height is also 2. So 2 times 2 times 2 is 8 pi. So now we can use that to find the surface area, because it's going to be the lateral area plus 2 pi r squared. Eight pi plus the radius is 1. No, the radius is 2 this time. Sorry, my bad. So that's 8 pi plus. So 2 squared is 4 times 2 is 8. So 8 pi plus 8 pi would be 16 pi, which, when you type that in, would be 50.27 inches squared. Okay, so it's clear to see when it says which can requires more aluminum to be made, it would be the tuna can, right? Because the surface area is 50.27 inches squared, whereas the surface area for the kickstart can was 31.42. Okay, and just an observation here, if you look, the lateral area was the same for both, right? They were both 8 pi. It's just once you factored in those bases, it made it so that the surface area of the tuna can was actually bigger. Okay. So yeah, that is the whole lesson for lateral area and surface area of cylinders. As always, if you have any questions, shoot me an email or a message on Schoology, or Mr. Voss if Mr. Voss is your teacher. We are both available to answer any questions you have. Just as a reminder, or I guess I just want to reiterate to my students, because I've been saying, thanks so much for all of you who've been keeping on track with all of this. I mean, it shows extreme maturity, and I don't know, it's just good to keep on track with all this, because it would just be too much if you fall behind. So I'm proud of all of you for doing all the work, and keep it up. But anyways, besides that, have a great weekend, because it is Friday. Happy Friday.